Okay. Hello, guys. Am I audible? Am I visible? Just put a yes in the chat if I am right. Okay. Not so comfortable with live streaming, but let's see today. Okay. Great. So, hello, guys. Welcome to the second session of dynamic programming of the Inter IIT Competitive Programming Conclave Presents Summer Camp. So just a quick recap and then we'll start with the lecture, right? Because it is very important to acknowledge the people who have made this possible. So just a quick recap. What is the IICPC summer camp? The thing is the Inter IIT Competitive Programming Conclave. We wanted to do something for the competitive programming community. So we were like, let's host a camp. And we were very clear that we want to make it free for all. So we planned and we started out with this camp. It was organized by Aditya Mishra, Ayush, and I have also helped in organizing a bit. Apart from this, talking about our sponsors who actually made it possible, we have AlgoZenith. So guys, for people who don't know what AlgoZenith is, first of all our camps, resources, all the videos, all of that will be uploaded on mang.in. The link will be shared below so you can have a look. AlgoZenith is a premium platform for internship and placement preparation. One of the key highlights is that there are many tier 3 and other students who are not from CS, CES, electronics and so on, who have cracked Google and so on and so forth. So one more thing about AlgoZenith, it was founded by Vivek Gupta, who's an international master on Codeforces, and he's an ICPC world finalist, not to mention he's an ex-Googler. So that is about AlgoZenith. The second sponsor is 0xPPL. A fun thing about 0xPPL is that it was founded by a person who was India #1 during his time, talking about Prasanna Sankar. The thing is, Prasanna Sankar has already founded a company called Rippling, which is a $10+ billion company. So they were very kind. Both of these sponsors were very kind to sponsor this camp. So thanks a lot for them. And now let's get started with the second session of dynamic program. So guys, before getting started with the camp, let me just tell you what we'll be covering today. So we'll be covering 4 problems today because I wanted the second session, I wanted to cover more on problem solving and answer construction, what is answer construction, so on and so forth. So we'll be doing that today. The first, we are going to solve a 1500 rated problem called boredom. The second problem we are going to solve is woodcutters. Okay. Third, we are going to look at what is answer construction and then how to find LCS and then how to construct the answer, so on and so forth. And then we are going to look at a very standard problem, which is LIS. Why I'm going to end at such an easy problem? Because in the next session, I'm going to show a very amazing optimization on the same problem. Sounds great? Video is lagging. Is it lagging too much? Is it manageable? Tell me guys, what is the scene? Let me just do one thing. Just close this and yeah, let me know. Is it manageable? Is it too much? I'm not sure, right? It's fine. Okay. Great. So let's start with the first problem, right? It's a very standard kind of problem, but it's a new problem. It's a new kind of thinking. So I thought it will be a great problem to cover. So what is this problem all about? It's called boredom and it's on Codeforces. I'll share the links later. Alex doesn't like boredom. That's why whenever he gets bored, he comes up with games. One long winter evening, he came up with a game and decided to play it. Given a sequence A consisting of n integers, the player can make several steps. In a single step, he can choose an element of the sequence. Let it be, let's say, AK, where K is the index and AK is the element, and delete it. At that, all elements equal to AK plus 1 and AK minus 1 must be deleted from the sequence. That step brings AK points to the player. Alex is a perfectionist, so he decided to get as many points as possible. Okay, and there is a simple example given. Let's take this example. Okay, so in this example, let's say Alex first took the number 1. Since he took the number 1, he gains 1 point, and then 2 gets deleted, right? After that, he chose 3, let's say. So 2 and 4, whatever they are in the array, they get deleted, and he adds 3 into his answer. So his final answer is 4 plus 2. Now, let me share what the problem actually is asking. And I'll take this example 1, 3, 2. Okay. So the array is 1, 3, 2. And what are we asked? Alex is playing a game. What does he have to do? He has to choose an index K. Okay. After that, what is going to happen? Add AK to your answer and delete all elements equal to AK minus 1 and AK plus 1. Okay, this is what the problem statement is asking. And what do we have to find? We have to find the maximum score possible. This is basically score. So maximum score possible. Okay. Is the problem statement clear, guys? Tell me. Put a yes in the chat if the problem statement is clear. Just reload my. Great. Right. So now that the problem statement is clear, we'll look at a very quick example. Let's take the numbers 1, 3, 2. So what are we going to do, right? Let's say Alex chose the number 1. So in his score, he's going to put 1, he's going to add 1, and then he's going to delete all numbers equal to 0 and all numbers equal to 2. So he deleted 2 and he deleted 0. So this gets removed, and this also gets removed because he chose it already. And the new array that is formed is 3, and he has 1 in the score. Now he chose 3. So 1 plus 3, the score becomes 4, and then the remaining array is empty. Does this make sense, guys? Is it clear? It's not clear? Tell me, guys. Oh, is it lagging too much? Great. Great. Okay. Question is clear. Great. So now let's solve this problem step by step. Okay. The first thing that the problem says is that when you choose a number AK, let this AK's value be X. Let's say we chose 3. Okay, X is 3. What do? We delete everything equal to 2 and everything equal to 4. Basically, we delete everything equal to X minus 1 and we delete everything equal to X plus 1 in the array. If the array was 2, 2, 2, and then 3, and then 4, 4, 4, 4, keep in mind that after choosing 3, I add 3 to my answer and I delete all elements equal to 2 and all elements equal to 4. Is this much clear? Some people say the problem is not clear. Please do let me know what is not clear, right? It is AK and then plus 1. Yes, for all indices. Yes. For example, if it is 1, 1, 3, 1, 1, 2, and let's say 5, 6, if I decide to choose the number 2, so all numbers equal to 3 and all numbers equal to 1 get deleted. So after this, the remaining array is 5, 6, and my score is 2 because I chose the number 2. Okay, great. So now it makes sense. I want to ask you a very simple question, guys. A very, very simple question. If my array is something like this, okay, 1, 1, 2, 2, 3, 3. In one, I will get to the test cases later. Don't worry about that, right? If I choose the number 2 once, okay, I'm going to add 2 to my answer, and then I'm going to delete this one, delete this one, delete this one, delete this one. So I lost some score, and my array, this also got deleted. So my array is now 2. Does it make sense if I tell you that if I have chosen 2 one time, let's say I chose 2 in a previous operation, I am going to choose all occurrences of 2. For example, if the array is 1, 2, 2, 2, and then let's say 3, 5, 6, and on the first operation you chose the number 2, 1, 1 and 3 got deleted. Now when I will choose the second 2, there is nothing to delete. So I got 2 for free, then I got this 2 for free as well, right? So what is the basic observation here? The basic observation is that I will choose all elements equal to X if I have performed one or more operations with X. Okay, does this make sense, guys? If I choose a particular number and I do an operation, I'm going to choose all those numbers in that array. Make sense? Okay. So I have a very simple question to ask you guys. That let's say I chose the number X, okay? And in the array, count of numbers equal to X, count of elements equal to X is C. Then how much does my score increase by? Tell me, guys. I choose an element equal to X. I am going to do it. And the count of elements equal to X, basically the frequency of X is C. Then my answer increases by C into X, right? Okay. This is the second observation. So what was the first observation? I will choose all elements equal to X if I have performed at least one operation with X. And the second observation is if I am performing, I am choosing, like I will perform an operation with X, then I'm going to add C into X into my answer. Okay. Now, this much is clear, right? So, since this much is clear, the last and final step that will actually convert this into a dynamic programming problem. So let's say the array is 1, 2, 2, 3, 4, and let's say 3. Do you guys agree that I only care about the frequency of elements? Because in my answer, it doesn't matter where a particular element is. Only its frequency is going to matter. So does it make sense if I store the frequency of each element instead of the array itself? Will it make sense, guys? Tell me. Like if the array is 1, 2, 2, 3, 4, 3, or if the array is 4, 3, 3, 2, 2, 1, does it make any difference? Think about it, guys, and tell me. It doesn't make any difference, right? Great. So let me store the frequency of every element. Yeah, using a map or using an array, you can use any sort of those data. So I have 1, I have 2, I have 3, and I have 4. What are the frequency of these elements? 1 occurs 1 time, okay? 2 occurs 2 times, 3 occurs 2 times, and 4 occurs 1 times. Okay. Now, I have a very simple question to ask. Let's say we start at number 1. This is the magical part, okay? We have 2 choices here. Either I am going to perform at least one operation with 1, or I am not going to perform an operation with 1. Okay. So either I'm going to pick or either I'm going to not pick. Does it make sense, guys? Yeah. So if I am at number 1, okay, so I'll be like, either I'm going to do an operation with the number 1, or I'm not going to do an operation with the number 1. Now, guys, if I do an operation with the number 1, can I say that I am not allowed to do an operation with number 2? Because all of it gets deleted, right? Right? Yes, exactly. We have choices. If I pick number 1 or do operation with number 1, the next element I will go to make choices. Keep this in mind. I am saying I am going to do an operation with number 1. Then the next index or the next element I will go to is 3. Does it make sense? Because I have done an operation with number 1. I cannot do an operation with number 2, but can I do an operation with number 3? Yes. So in that case, I will go to number 3. But let's say I am not going to do an operation with number 1. In that case, I am going to go to number 2. Yes or no, guys? Tell me. Yes? Now, is the choices clear? Let me generalize this further. Let's say I am at number X. I have 2 choices. Either I'm going to pick this or I am not going to pick this. If I'm going to pick this, my answer increases by whatever the count of X was into X. And then I move to X plus 2. But if I don't pick this, my answer, like I'm going to go to X plus 1 and I'm going to repeat the same thing. I have 2 choices, so on and so forth. Make sense, guys? Chat, like, yeah. Just give me a second, guys. Okay. So now that this much is clear, let's define our dynamic programming solution. What do we mean by defining dynamic programming solution? Can you tell us again? Sure. See, we are at number X. Let's say we are at number 1. We have 2 choices, right? Either we can do an operation with number X, or we'll not do an operation with number X. If we do an operation with number X, okay, if we pick it, our answer increases by C into X, where Cx is the frequency of X, okay? Right? Because we just deduced that if I'm going to do at least one operation with X, I'm going to choose all the elements equal to X. Make sense? Yeah. After that, the second choice I have is I'm not choosing the number X. So in that case, I go to X plus 1. A very simple question to ask you. Let's say I have pick and I have not pick. Picking X will give me, let's say, answer A, and not picking X will give me answer B. Can you tell me which answer I'm going to choose? Like, this is my answer if I pick A. This is my answer if I don't pick X. What is the answer that I'm going to choose? Exactly. Maximum of A comma B. Exactly, guys. Great work. So if picking gives me answer A and not picking gives me answer B, I'm going to choose max of A comma B. Okay. So now the dynamic programming solution. I'm going to keep it very instructive. So whenever we are coming up with a dynamic programming solution, okay, what can we do? What do we have to do? We have to define states and we have to define transition. Okay. Transition is nothing but what we just did, and states is something we just need to store. We need it to store our dynamic programming solution, right? So can I say that dp of x defines the maximum possible answer from x onwards, right? Basically what I'm trying to say, let's say I am at number 2. dp of 2 is going to store what is my answer if I start at 2. Like if I am going through numbers 2, 3, 4, 5, 6, the entire sequence like that, what is going to be my answer? So can I say dpx is the maximum possible answer when I start with the number x? Yes? No, I know it might be a little mathematical and not so intuitive. It will be like, you can do both things, Debojit. It doesn't really matter. Okay. So now looking at the transitions, if we are at what is dp of x equal to, we know the transition. Okay. Now we have two choices, pick x and not pick x. Okay. If I am going to pick x, my answer or dp of x is going to be what? It is going to be frequency of x. So I'll name it c of x into x, because frequency into the number, plus dp of x plus 2. What is dp of x plus 2? dp of x plus 2 stores the answer when we start at x plus 2. Basically, I was at x, I did cx into x, and then I'm going to x plus 2, and I'm finding what the answer is. Okay. When I don't pick x, dp of x is dp of x plus 1. And as we discussed earlier, if this answer is something, this answer is something, what do we want? We want this answer to be maximum of these two. Does it make sense, guys? Is it hard? Like I shared the basic intuition behind it. We decoded the problems one by one. And in this problem, we just have two choices. Either we can pick, either we cannot pick. And then that comes by practice. But here we can see that which element we are on matters. Like otherwise, how would you store it, right? So that is why one of the states should be X, right? So now if we look at the problem, the numbers are only till 10 raised to 5. So how do I go about implementing this? Let's have a look in the code. If this much is clear, right? This is more or less the code itself. But if you want to look how to go about implementing it, let me show it to you. Just a second, guys. It's just loading. Yeah. Right. So what is going to be the code? I have capital N. What is capital N? The maximum length of the number, right? Like the numbers can be in the range 1 to 1e5. So I've kept my capital N as 1e5, which is 10 raised to 5. Okay. Then I have two arrays. One is frequency and the other is the DP array, because we need DP array for memoization. Keep in mind that it is capital N and it is not small n, right? So if what am I doing? I'm taking an input. I have an element. So int x, c in x, and then I'm doing frequency of x plus plus. Now for this is not index, actually, this is the number. Let me just change that. Just keep in mind, guys, this is not the index actually of the array. It's the number. It's the value. Okay. It's not index. I'm sorry for that. So this is what we call as a lambda function. I use it because I can code faster using it. You can use a normal function here as well. You can write it here. But this is just a simple function. What is it doing? It is having integer index as a parameter. If index is greater than equal to n, means if I have reached outside 1e5, right? I'm reaching at 1e5 plus 1 or 1e5 plus 2. The answer is always going to be 0 because there is no element greater than 1e5. After that, if dp index not equal to -1, basically return dp index, the memoization part. And as we discussed, dp of index is maximum of either you don't pick, so you go to f of index plus 1, or your value increases by index into frequency of index, and you go to f of index plus 2. Okay, Parth asks a very simple question. If we are on the fourth index, what about elements I minus 1? So, good question. Let me take that. Index is the value. Let me just take it one more time. So let's say it's 3, 2, 2, 1. Syntax of lambda function, you can see for yourself. I'll surely explain it to you all maybe. But okay, let's say I am at dp of 2. Okay. Let's consider this is the smallest element I am picking. Okay. This is the first element I am picking. Right. Now, if I pick this, do you guys agree I will go to dp of 4? Tell me, guys. I am at 2. If I pick this, I'm going to go to dp of 4. Now, if I choose to pick 4 as well, do you guys see that 3 in the first place was not picked? So I don't need to worry about 3. Because when I chose 2, I directly went to 4. I'm not picking 3. So I can pick 4 without any issues. Make sense, guys? If x is at 2 and at x plus 1 is 4, x plus 1 is not 4. We can. Those are not indices, Pranav. The index, like I think I confused you all, but it should be integer value, okay? Because it's frequency. There is nothing to do with index here. So in this case, I have two choices. Either I'm going to pick this value or not pick this value. If I pick this value, then I'll go to value plus 2. Otherwise, I'll be going to value plus 1. Clear, guys? The time complexity of this is big O of capital N, which is 1e5. So it runs within 1e5 operations. Yes, you can do that as well. Just for teaching, I started from f of 1. But yes, Chinmay, you can start from f of minimum element as well. That works. We will start with the lowest number, that is 1, right? Exactly XYZ. Since 1 is the smallest number, we will be starting with f of 1. Devjot asks, can we do it iteratively? Yes, we can do it iteratively. I'll be covering mostly recursive DP for this particular class. In the next class, I'll be starting with iterative DP. The reason why I chose to stick to recursive DP is much easier, much more intuitive to understand when someone is starting out with DP. But yes, after you solve 15 odd problems, a great practice to start out with iterative as well. Great. Why is the time complexity not 2 raised to n? Because I am memoizing my solution. Like if you can see over here, that although I have two choices over here, if I hadn't memoized it, like if I didn't have this uh, line here, it would have been big O of 2 raised to n. But f of index gets calculated one time. So whenever the next time it is being calculated, it directly gets returned and it doesn't make any other function calls. And how many unique such indexes are there? There are 1e5 unique indexes, right? So that is why the time complexity is big O of capital N. I hope it makes sense. Then makes sense, guys. But our state is picking x onwards. If we pick, we are going to x plus 2. That is picking x plus 2 onwards. What about 1 and x minus 2? I'm not sure about your question, what you're trying to ask. We'll definitely get into it. Okay, I can write it from scratch as well. I don't have any issues. Let me write it from scratch. Like, do majority of people understand, or do you guys want me to start from scratch? Just put it in the chats below. Like, do you want me to code from scratch, or do you want, like, it's fine for this problem? Just put rewrite and I will rewrite it for this problem, or from the next problem I'll take it from scratch. Okay, majority people say understood. So I'll share the code as well. So great. For lambda functions, guys, if you guys want to know what is lambda function, let's say I have a normal function, okay? Let's say int f, and let's say int a, int b, and int c. And I'm doing something over here, okay? I'm going to give you a very nice instructive lecture on how to write lambda functions as well. So I want to do the same thing using a lambda function. How do I do this? So first of all, I write function and I open this bracket, okay? What is this function returning? It is returning an integer type. So I'm going to write int here. After that, I'm going to open round brackets. And you can see that all three parameters are of type int. So what are the three parameters? It's int, comma, int, comma, int. Okay. And what is the name? F. So that is how you define a lambda function. Here, giving ampersand gives it scope of its parent. Basically, if you want the lambda function to access something in its parent function, you can do it by adding ampersand. And then it's just writing this, right? So it has int a, it has int b, and int c. And here you can write whatever you are writing in a normal function. Yeah, I can zoom in as well. Okay. So if this is my function, if I wanted to write it as lambda function, it is function, then angular brackets, then integer, then inside integer, then f is equal to, sorry for that, and then ampersand int a, int b, int c, then you can do whatever you want to do, right? So that is how you write a lambda function. It is lambda function for you all guys. Okay. Yes, it is a bit more inefficient than the normal function. It has some bad constant, but it's a personal choice. If you want to use it, you can use it. If you want to use these functions, which are the fastest, you can use that as well. Okay. Moving on to the next problem. This is a bit of a challenging problem because we want to, because there are some cases here, but let's move on. Great. So congratulations, guys. You were able to solve the first problem. We were able to solve the first problem. Now moving on to the second problem. Woodcutters, right? Little Susie listens to fairy tales before bed every day. Today's fairy tale was about woodcutters. And the little girl immediately started imagining the choppers cutting wood. She imagined the situation that is described below. There are n trees located along roads at points with coordinates x1, x2, x and so on and so forth. Each tree has its height h1, hi. Woodcutters can cut down a tree and fell it to either left or right that occupies one of the segments, either xi minus hi, 2xi, or xi to xi plus hi. The tree that is not cut down occupies a single point with coordinate xi. Woodcutters can fell a tree if the segment to be occupied by the fallen tree doesn't contain any occupied point. Okay, the woodcutters want to process as many trees as possible, so Susie wonders what is the maximum number of trees she can fell. Okay, so here xi and hi are up to 10 raised to 9. Your array elements are 10 raised to 5, and the elements are in sorted order of xi. Basically, the points which they are given, they are sorted. So let me just quickly write this down on my tablet and then I'll explain the problem to you guys. Okay. Let me just quickly write this down. 1, 2, 2, 1, 5, 10, 10, 9, and 19, 1. Okay. So guys, this is the first input. Okay. So what does this mean? Consider your x-axis. Okay. At x is equal to 1, there is an tree with height 2. At x is equal to 2, there is a tree with height 1. Okay. At x is equal to 5, there is a tree with height 10. And at x is equal to 10, there is a tree with height 9. At x is equal to 19, there is a tree with height 1. Okay. Now for each tree, let me just draw. It doesn't look like a tree, but assume that it is a tree. I am a competitive programmer, not an artist. Okay. So for every tree, I can either make it fall to the left or to the right. If I decide to make it fall towards any point, I have to make sure that no other tree is there already. For example, if you look here, this height of this tree is 2. So I can't really make it fall here because there is a tree at this particular section already. Like even if I make it fall anywhere, the base of the tree is going to be stuck at 2. Okay. So I cannot make this tree at point 1 fall here because it will be occupying the point 1 to 1 plus hi, which is up to 3. Basically, it will be occupying the range 1 to 3, right? So it will be covering this tree or overlapping with this tree. So that is not allowed. But if you look at, if I want to make it fall towards the left, right? So what do? We can make it fall in the range -1 to 1. Okay, because if I make it fall, its base is going to be at 1. Then it is 2 centimeters long. So it will be from 0 to -1. This is the range. And since there are no trees in this range, I can feel free to do this. Okay. I want to find what is the max trees. What are the max trees I can fell? Is this much clear, guys? Tell me. Is the problem statement clear? Yes, no. Let me just reload. I'm okay. Lightning says yes. What about others? Shreyas says yes. Omik says yes. Yes, we can fell a tree on negative x-axis as well. It doesn't really matter. It should just not cover any other tree. Okay. Great. So guys, the first thing I want you all to notice is that let's say I have a tree and I have, okay, it's at point, let's say 3. There is a tree at point 5. The height here doesn't matter. Here it is something, and let's say at point 1, there is another tree and its height is also y. It doesn't really matter. Okay. Do you guys agree that no matter what I do, I cannot make this tree fall anywhere if its height covers its adjacent element. Let's say its height was 2. Okay. So if I make it fall towards the left, it is going to cover 1 to 3. That is not possible, right? Because no matter where I make this tree fall, either towards the right or towards the left, the base is always going to be at 1. So if I make this fall towards here, this one and this one will overlap, which is not allowed. Similarly, here, if I try to make it fall towards the right, if it falls, it will be occupying the space 3 comma 5, right? If it falls over here. But no matter where I make this tree at 0.5 fall, it will always overlap with this 3 comma 5 because the base is fixed at 5. So does it make sense when I say that I can only and only make a tree fall in a particular direction if the distance from this tree to the next tree is greater than its height? Like if this was 6, okay, let me just erase this. Instead of 5, if it was 6, since it occupies 3 comma 5, and let's say I've not decided to make this fall or not, I can make this tree fall in the range 3 comma 5. But why can't the top of the second tree be? Because that is the rule of the problem. The problem defines that you cannot do it, right? We can't ask the problem setter that why isn't it not allowed. Yeah, we can't do that. The problem says so, that if it doesn't occupy a point. Kritik says, when are you going to take attendance? I sure the moderators will roll out an attendance form soon or take the attendance soon. Don't worry about that. Okay. We're here to learn, right? Attendance is just great. So, what is the first observation that we are making? If I want to make it fall towards the left or towards the right, okay, let's say I am at a particular index, I can either make this fall towards the left or towards the right. Okay. I can make this fall towards the left. Okay. Let's say I have not processed any other trees. I have not made any other tree fall. Only and only if this is x of I, this is x of I minus 1, this is x of I plus 1. And it has heights h of I minus 1, it has height h of I, and it has height h of I plus 1. Okay. So if I want to make this tree fall towards the left, can I say that is only possible when xi minus 1, okay, these are the indexes, is greater than h of I? Can I say this, guys? Basically, let's say you have a tree at 1, 3, and this height is 2. Consider you are at this tree. And similarly, consider that point is 0, this is 3, and again the height is 2. Okay. You cannot really make this tree fall this side because it will be occupying the points 1, 2, 3, which will be intersecting with this tree. So that is not allowed. But when I'll be trying to make this tree fall towards the left, xi minus 1, which is 3 minus 0 is equal to 3, which is greater than 2. Hence, it is allowed and I can do that. Now, if you guys understand this, give me the condition. If I'm at index I and I want to make my tree fall between these 2 points, okay, there is xi, there is xi plus 1, there is hi plus 1, and there is hi. Okay, and this is sorted in xi, so it doesn't really matter. If I want to make this fall between xi and xi plus 1, what should be the condition? I'll give you a couple of minutes. If like you can just write it down in the chat, I'll be waiting. Just Yes, Carrie was the first person to state it out. So yeah, xi plus 1 minus xi should be greater than hi because I want to make hi fall and the distance between these 2 points is xi plus 1 minus xi. Great. Is this clear for everyone? Like, I know how to make it fall. Okay. Yes. Great. So, just to do a quick recap, if I am at index I can make it fall towards the left if xi minus 1 is greater than hi. Similarly, I can make it fall towards the right if if xi plus 1 minus xi is greater than hi. I hope these two conditions are clear. Tell me, guys, are these two conditions clear? Yes, no, great. Okay. Yeah. So someone asks a very interesting doubt. Hey, Gaurish, what if we are at the first index where I 0? There is no element towards the left. Can I make this fall towards the left? Tell me, guys. Can I make the first tree fall towards the left? Tell me. This is the condition, but does I minus 1 exist? It does not. So you are right. So if I 0 and I want to make it fall towards the left, I can make it fall towards the left always. Similarly, let's say I am at I is equal to n minus 1. Can I make it fall towards the right? For I is equal to 0, I can make it fall towards the left. For I is equal to n minus 1, similarly, can I make it fall towards the right? Yes, great. Okay. So now, if this much is clear, let's move on to okay, we formulated some things. How do we think about this in terms of dynamic programming? Okay, like how do we think about this? So, what I want you all to assume is that let's say you have a bunch of trees. Okay, these are the bunch of trees, and I'm going to make them fall in order. The thing I want you all to assume is that let's say there exists an optimal falling sequence. Like, let's say it says that make this tree fall over here, let this tree be as it is, let this tree fall over here, let this tree be as it is, and let this tree be fall over here. This is the answer that the judge has created. Okay, this is the most optimal answer that is possible. Okay, can you guys tell me that if I'm iterating like this, first I am at this tree, can I form this sequence? Like, I am at this tree, I make it fall towards the left. Okay, then I go to this tree, then I don't make it fall. Okay, then I go to this tree, then I make it fall towards the right, and then I go to this tree, I don't make it fall. Then I go to this tree and I make it fall towards the right. So if this is my most optimal answer, if someone tells me like, Gaurish, this is the most optimal answer, this is the final answer, can I generate this sequence by traversing in order? Put a yes in the chat if it is clear, right? Let me just reload my YouTube. I'm having some internet connectivity issues, right? Okay. Okay. So now that it is clear that we can generate the optimal answer by traversing from left to right, right? So the thing is, we can iterate over indices. This is the observation that we get. We can iterate over indices rather than doing some random moves. Okay, like this sequence we could have formed anyway, like first following this, then this, then this. But giving more structure to our problem, we can go from left to right and we can attain the same sequence. Okay. So this is the first observation. Now, I want you all to assume that I am at index I. Okay. I have traversed from index 0 and I am at index I. Right. There is a tree. I want to know if I can make it fall towards the left or I can make it fall towards the right. Okay. Greedy does not fail in this problem. You can do a greedy as well. I took this problem so that I wanted to teach a very not so obvious way of dynamic programming. Like majority of, yes, you can do it using greedy as well. Yes, there is a greedy strategy to it, but I won't be really discussing that because it'll make people confused. Like, right? Okay. So let's say I am at index I. Getting back, guys. I'm at index I. It is at position xi, and then it has height hi. Right? I want to know if I can make it fall towards the left or if I can make it fall towards the right. Right? If I want to make it fall towards the left, I know one condition that xi minus 1 should be greater than hi. Keep in mind that I have already processed all trees from index 0 to I minus 1. Okay, these are already been processed. Can I say that this condition is sufficient? Tell me, guys. Is this sufficient? Like I am iterating over trees from left to right. I have already decided some way they are going to fall. Is this the only condition I need to check for? No. So what condition, guys? Tell me. Apart from this, what other condition do I need to check? Anyone? Anyone in the chat? Let me just my phone. Right. Great. So guys, the thing I want to know is, let's say I am at index I, right? Majority of you are saying it right. If I am at index I, there is a tree at index I minus 1. There is a tree at index I plus 1. I don't really care about the tree at index I plus 1 right now because I want to know if I can make it fall towards the left. It might, since I have processed all these elements, okay, it might be very well possible that I made this tree fall towards the right. Yes or no, guys? Since I am processing these elements this way, it might be possible that I made this tree fall here. Yes or no? Tell me, guys. Yes? Yes? Great. So I need to know if the previous tree, if I'm at the index I want to know, has the previous tree be fallen towards the right? I'll take a very simple example, okay? If this is 0, this is 3, this height is 2, this height is, let's say, 2. I am processing these elements like this, okay? If I make this tree fall towards the right, it occupies the space 0 to 2. Now I came to this tree. Can I make this tree fall towards the left? Tell me. No? Great. So very simply, guys, what is the observation here. I'll just explain the problem and then look at the chat. I realize that I am taking up a bit of time looking at the chat, which I don't want to ruin the experience for y'all. So simply, guys, if I am at index I, it is very important to know for me if the previous index has been made fallen towards the right or not. But there is one more case I want you all to consider. If I'm at 0 and if I'm at 5, okay, there is a tree here, there is a tree here. Let's say its height is 2, let's say its height is 2. I make this fall towards the right. So it occupies the point 0 to 2. You can notice that I can still make this fall towards the left because it occupies the points 3 to 5. These two don't intersect. So tell me, guys, if I want to make a tree fall, I'm at index I know like either a tree has been, the previous tree has been fallen towards the right or fallen towards the left. Now, can I say if I can make it fall towards the left or right? Because let's say I'm saying that yes, the previous element, the previous tree was fallen towards the right. Then the distance gets shorter, right? It's like um, xi minus 1 minus hi. Isn't this now hi minus 1? Isn't this the condition we should be satisfying? Yes? Great. So now if this much is clear, how do we solve this using dynamic programming? One thing that we saw was that we need to know if the previous tree was fallen towards the right or not. Okay. Okay. We need to know this. So defining a dynamic programming state, dp of I comma j represents that I am at index I. Okay. And j can have two values, 0 or 1. It will be 1 if the previous tree or the previous tree that I like what I did with I minus 1. If I made it fall towards the right, it is going to be 1. Basically, made I minus 1 fall towards the right. Otherwise, it is going to be 0. Otherwise. Does it make sense, guys? We don't need to store coordinates, but yes. Let's say I am at index I. J represents, has the previous tree been fallen towards the right or no? Okay, great. So very simply, guys, let's say I am at tree I and let's say this is 0 for now. Similarly, we'll consider a case when it is I and it is 1. Do you guys agree that when I'm at index I have three choices? Okay, either I can make it fall towards the left, or I won't make it fall, or I will make it fall towards the right. Similarly, for this also, we have three cases. I'll make it fall towards the left, I won't make it fall, and I will make it fall towards the right. For all these conditions, we have a check, right? If I want to make it fall towards the left, I know that the previous tree hasn't been falling towards the left. So the only condition I need to check for is something that we already discussed, which is xi minus 1 greater than hi. If it is 1, then we need to check if xi minus 1 minus hi minus 1 is greater than hi. Does it make sense? Like I can only take this choice if I'm at index I, and if it is 0, then I can make it fall towards the left if this condition is satisfied. If it is 1, I can make it fall towards the left if this condition is satisfied. Yes or no, guys? What if I minus 2 has very tree big height and that is inferring? Okay, Praveen, very good question. I will just make you understand. If I have trees here, Praveen asks that if I'm at index I, why does it not matter where this tree is falling? And why does it only matter why this tree is falling? Because since this comes before this tree, okay, if I want to make this tree fall, I can make this tree fall only in this range. Like I cannot really make this tree fall further than this. Similarly, for ahead, I cannot make this tree fall in this range. I can only make this tree fall in this small range. So where this tree falls doesn't really depend on where the second last tree has fallen. Make sense? Yes, no, maybe. Okay, great. So getting back to our choices, let's not waste more time. If this condition gets satisfied, which is xi minus 1 is greater than hi when j is 0, then this choice is valid, right? What do we want to find? We want to find the maximum number of trees we can fall. So dp of ij represents the maximum trees we can fall if we are at index I and the state of the previous tree is given by j. Okay, this is our dynamic programming state. So if we are making this fall towards the right, our answer increases by 1 and we go to dp of I plus 1 comma 0. Why do we go to 0? Because the previous tree, like I, we made it fall towards the left, not the right. So this remains 0. Similarly, if I do not make this fall, okay, I don't make this tree fall. Let me just make this much more clear, okay? It's getting too hectic. So I'll just explain it again. Okay. dp of I comma 0. Okay. What does this represent? I am the maximum trees I can make fall if I am at index I and the previous tree condition was j. Okay. I hope this much is clear. Now, if this much is clear, the first case is I is something and j is 0. So I can either make it fall towards the left or I won't make it fall or I will make it fall it towards the right. This is when xi minus 1 is greater than h. In this condition, my answer will increase by 1 and I will go to I plus 1 comma 0. Similarly, when I do not make it fall, I can go to I plus 1 comma 0, but my answer will increase by 0. When I make it fall towards the right, I will go to I plus 1 comma 1 and my answer will increase by 1. And what is the condition to make it fall towards the right? It is xi plus 1 minus xi should be greater than hi. Is this much condition, is these conditions clear, guys? If I'm at index I and the previous tree hasn't been fallen towards the right, so this condition is for making it fall towards the left, this condition is for making it fall towards the right, and I have three options: make it fall towards the left, make it fall towards the right, and make it not fall. Yes? Okay. Now, one more question. Let's say this further gives you answer X, this gives you answer Y, this gives you answer Z. Which answer are you going to choose? Tell me, guys. Which answer are you going to choose? Isn't it going to be max of X comma Y comma Z? Maximum of these answers? Yes, great. So if I have answer X, I have answer Y, and I have answer Z, I choose maximum of X comma Y comma Z. Similarly, if it is I comma 1, okay, I have again three choices. I can make it fall towards the left, I won't make it fall, and I can make it fall towards the right. Okay. If I want to make it fall towards the left, now the condition is different. Why is it different? Because the previous tree was made fall towards the right. So the condition here is xi minus 1 minus hi minus 1 should be greater than hi. This is the index, right? Similarly, for right, it should be xi plus 1 minus xi should be greater than hi. And this doesn't have any condition. Similarly, there'll be plus 1 here, plus 0 here, there'll be plus 1 here. And here I'll be going to I plus 1, comma 0. Here also I'll be going to I plus 1, comma 0. And here I'll be going to I plus 1, comma 1. Clear, guys? Tell me. Are these transitions clear? Are your choices clear? Yes, yes, you can do a greedy here, but since we are learning dynamic programming, I wanted to take up this problem and try to make you all understand how to think about this problem in terms of dynamic programming, because it's a very neat problem. There are a lot of cases here, so that makes it interesting. Okay, so this is more or less your solution. And trust me, guys, if you can come up with your dynamic programming states, if you have your choices, these choices and where they go, it's known as transition. Okay. And this thing right here, what you're iterating on, is known as the DP state. So that is all that matters. Like I can show you the solution as well, but I would love if you can code it by yourself. I want you all to try first. Full stack web dev asks, ironically, in a competitive programming lecture, in previous case, why not make it fall towards X, as it will be a better option. Next tree is larger, so better than Y max. Very simple. Let's say I made it fall towards the left and the answer I got was 10. If I didn't make it fall, answer is 11. If I made it fall towards the right, answer is 12. I want to find the option that gives me the most answer, right? Because what is dp I comma j defined as? It's the maximum number of trees. So whichever option gives me the maximum answer, I'm going to pick that up. Yes, guys, don't really care about attendance. We are here to learn for the love of competitive programming. Yes. So is this problem clear? Like I'll show you the implementation quickly. Like just give me a second. Yeah. Okay. I'll code it from scratch. Okay. So let me just code it from scratch. What is answer here? Answer is the maximum possible answer, right? Just give it a second. My internet is a bit slow. So yeah. I'm not showing the answer. I'm coding it from scratch. Just give me a second, guys. Just I'll cover it. It won't take much time, Samir. Don't worry. I can code fast. Just internet is what is stopping me today from coding fast. You can leave the implementation for us and give us the submission link. Okay, let's have a vote. Okay. Do majority of you all want to try this problem on your own, or do you want me to give the implementation? I have explained everything in the solution except the implementation. Will you be able to implement it by yourself? Own. Okay. If you want to do it by your own, write own in the chat. If you want me to code it, you can just say code. Okay. I'm sorry if I missed someone's question. I'm actually on my phone and it's very small. So I'm unable to see everyone's chat. So I'm sorry for that. You can just put it down again. I can't really help it. I wish I could. So great. I'm actually very proud of you all that you want to try it out by yourself. That's actually the first step in improving in competitive programming. The will to do it by yourself. So keep it up. I will obviously share the submission link. I would love if the moderators could just take my submission link and share it in the chat. just in case someone wants to refer it. Yes, sure. Now moving on to the third problem today. Okay, this is a new kind of problem. Initially, we have been looking at we need to find an integer or something like that. In this problem, the answer is a string. So we are like, how do we actually do it? This problem I'll be implementing as well as coding out from scratch. So don't worry about that. Okay. So what does the problem say? You are given strings S and T. Find one longest string that is subsequence of both S and T. Okay. For example, we have A, X, Y, B. Let me just zoom this in. And we have A, B, Y, X, B. Right? What is the most longest string that is a subsequence? What is a subsequence, guys? Like A, Y, B is a subsequence, but A, Y, X is not a subsequence because they are not in order. Basically, if I choose A, then let's say I choose B, Y, and then B, A, Y, B is a subsequence. Okay. So given two strings S and T, let me just write it down. Okay. These are the two strings. So given two strings S and T, our job is to find the longest common subsequence. Yes or no, guys? Tell me. In this, I think the answer is AXB or AYB. Both are answers that are possible. If you look at it, it's AXB or you can have AYB. Yes. Let me just take this down. Okay. So is the problem statement clear to everyone? Typical DP question. Ramesh, actually, the thing is that this type of problems are not intuitive for everyone. Like here, if we wanted to find the answer, okay, it's a bit easy. But how do you come up with the string that gives you the answer? Okay. Like here, if I wanted to print the answer, maybe it's a easier question. I would print 3, but I have to print a string, which is a much harder question to deal with. Okay. So I want to make you all think intuitively for this question. Okay. So A, X, Y, B and A, B, Y, X, B. Okay. These are the two strings. Now tell me, guys, if I wanted to find the longest common subsequence, what is one thing that we could do? I'm audible, right? Just put audible in the chat if I'm audible. Soil says that's a sound problem. What kind of sound problem? Audible. Great. Great. Yes. So let's say in my answer, okay, I have X. So A, X, Y, B and A, B, Y, X, B. Okay. In my final answer, let me just choose some other color. Let's say blue. Okay. I have chosen this X and this X. Okay. I have matched it. Can I say, if you think I've taken two problems where I've make you all think how to think recursively. Okay. I chose this X and I chose this X. Okay. I've processed the strings from here to here, processed the strings from here to here, and I'm like, okay, this is going to be a part of my LCS. Do you guys agree that now what is my job? I have fixed these two elements. Okay. That this is going to be part of my LCS. Now my job is to find the LIS in this range and in this range. Yes or no, guys? Tell me. Let's say I fixed X and X, I've processed till here. I'm like, okay, I'm going to match these two. Now what is my next job? I have to start with these elements and I have to find my LIS in this range. Yes or no, guys? Is this clear? Like, is this idea clear? Like, this is not the solution. I'm just giving you a basic idea. Is that much clear? Yes. Okay, great. So, very simple thing. What are we going to do? Here, I need to know which element I am fixing. And here also, I need to know which element I am fixing. So since you're in the advanced cap, one simple thing I am assuming you guys know is two pointers. Okay. So let's say I have the strings AXYB and I have the strings ABYXB. Okay. Those were the strings. I have one pointer here and I have one pointer here. Think about it as a very naive two pointer solution. Okay. Let me just write it down here. So now with these two pointers, I have some options. Can you guys list down what options I have? Let's call this pointer I. Let's call this pointer J. Okay. What options do I have? I am at I comma J. Okay. Now, if Si is equal to Tj, this is string as this is string T. So if I is equal to J, okay, if Si is equal to Sj, what can I do? I can say that I'm going to fix this. Okay. If I fix this, guys, now my job is to find the LIS in the other string. So where do I go? I go to I plus 1, J plus 1. Basically, I'm saying that, okay, in my subsequence, I fixed this. Now I'm going to find my answer in the next part of the string. Make sense, guys? Yes, move both ahead. Exactly. Right? Let's say you're at any arbitrary point. Okay. Just, yes, great. Now, if Si is not equal to Sj, right? Now I can be stubborn. How can I be stubborn? Let me tell you. And what do I mean by being stubborn? My one pointer is at I and one pointer is at J. I can say that I want this in my LCS, but this is not going to be in my LCS. So I'll be like, okay, I will move J one step ahead and see what happens. Similarly, I can be like, no, I want J to be in my LCS, TJ to be in my LCS. So I will move I one step ahead and see what happens. Basically, the intuition I'm trying to give you all is, let me just write it down. Let's say it's BA and it's AB, or let's say this BCA and ACB. Okay. I have I and I have J. These two don't match. So I can be like, okay, I want J in TJ in my LCS, which is A, or I want this B in my LCS. Now, if I want this A in my LCS, do you agree that this has to go here? This I has to go to I plus 2. Like if this is 0, 1, this has go to 2. Is this much clear, guys? Like if I say that this has to be in my string, I will have to go to the next occurrence of A. But let's say I'll say that I want this B in my string, then J will have to be shifted here. Yes, no, is this much clear? Not clear? Like I'm giving you a basic idea. Yes, no, yes, great. Si is equal to D. Yes. Now, I'll give you a very simple explanation why instead of at I comma j, instead of going to I comma j plus 2, okay, like here in this case it was j plus 2, why going to I comma j plus 1 will be sufficient? Okay, very simple. If I am at I comma j, my target is to reach I comma j plus 2. Now if I go to I comma j plus 1, here again I have two options. Either it will be I plus 1 comma j plus 1, or it will be I plus 1 comma j plus 2. So I just simplified my choice. If I go to j plus 1, I will eventually end up reaching going to uh, this is not I plus 1, this is I comma j plus 2. I will end up reaching going to I comma j plus 2. So I don't really need to search where the next element is. I can believe in my recursion that it will eventually reach somewhere. So if I'm at I comma j, I can just simplify these to two choices. Either move my I pointer one step ahead or move my j pointer one step ahead. Because let's say I am fixing I, so end of the day it is going to go ahead. And similarly, if I'm fixing j, it will be going ahead, so on and so forth. Make sense, guys? Yes or no? Tell me. Yes, no. Chinmay says repeat SI not equal to SJ. Great. Let me take that. If SI is not equal to SJ, I have two choices. Either I can TJ, okay. I can say that I want SI in my LCS or I want TJ in my LCS. If I want TJ in my LCS, I'm just going to move my I pointer ahead one step. Basically, let's say it will go anywhere ahead, but I am recursively defining it is that just go one step ahead right now. And similarly, let's say if I want to fix SI, then I will say that move your J pointer one step ahead and let's see what happens. Make sense? Yes or no, guys? Like, because let's say my most optimal thing was I comma J plus 7. Don't you guys see that this will go to I comma J plus 2 and so on and so forth? So eventually this recursion is going to reach I comma J plus 7. This is not my DP solution. I am getting towards there. I'm showing you the choices that we have to make right now. So great. So very simple. Since we want to have two pointers, one I and second one J, this I is going to take values between 0 to n minus 1. This J is going to take values between 0 to n minus 1. Okay. So can I have a DP of I comma J if n is smaller than equal to, let's say, 2000? What can I say? If Si is equal to Sj, then I can go to DP of I plus 1 J plus 1. Basically, I'm taking this as a part of my LCS and I increase my answer by 1 because I added a string, right? I added a character. But if Si is not equal to Sj, then I have two choices. Either move to I comma j plus 1 or move to I plus 1 comma j. Does it make sense, guys? Make sense? Great. Okay. Now, how do we define our dynamic programming solution to be? DP of I comma j. What do we define it as, guys? It's very important. Whenever you're solving a dynamic programming solution, keep this in mind. It will help you get better at dynamic programming. It represents the max size of LCS we can create such that we are in index I to n minus 1 and we are in string t from j to m minus 1. This is our dynamic programming state. DP I comma j is the maximum size of LCS such that I am in string s from I to n minus 1 and in string t from j to m minus 1. Okay. So if si is equal to sj, then we are going to pick it. So our answer increases by 1 and we are going to dp of I plus 1 comma j plus 1. Otherwise, we have two choices. Either we move the I pointer ahead by 1 or we move the j pointer ahead by 1. Okay. And let's say this is dp and dp. Similarly, since it's the max answer, we are going to pick up the max of these two values. Is this much clear? Tell me, guys. Yes, dpi comma j is like we have covered all indices before that, and now we are at I comma j. I want to find the maximum answer such that we are starting at I comma j and then we are going at, like we are starting at I, like we are starting at index I and we are starting at index j. Make sense? Okay. So, but the question is, this returns an integer. How do we make this into a string? You'll be like, Gaurish, this problem we can solve. It's an integer problem. How do we find the string here? Yes or no, guys? Do you guys have this doubt in your mind? Tell me. Yes, no, or is my internet lagging? Yes, you guys do have this doubt in your mind. Why did you add 1 plus in your DP? Because if SI is equal to TJ, sorry, if SI is equal to TJ, I'm going to add it to my LCS. Basically, let's say it's A, B, and let's say C, B, X, Y, Z, and YZ. If I am over here, I'll say that, okay, I've picked this one in my answer. So the length increased by 1, right? So my length increased by 1, and then I'm iterating one step by. Make sense now? Pranav, doesn't make sense now. Great. So now, from bringing the answer 3 to finding the solution, like ABXY to AXYB, our answer here is 3 and our solution is going to be AXY. So we have to find a way to go from this 3 to go to AXY. Now there is a very neat trick to solve this, and let's have a look how to do it. Okay. So what we can do is I am going to show you all the dynamic programming uh, table, the DP table, what it creates. Okay. So these are 4 characters and these are also 4 characters. So this is A, B, X, Y, and let's say this is A, X, Y, B. Okay. So when I am over here, when I's, let me just write down 0, 1, 2, 3, 0, 1, 2, 3. Okay. We'll start filling this from here. These both are not equal. So I am at 3 comma 3. Okay. So I will either go to 3 comma 4 or 4 comma 3. Since both of these are out of ranges of our indices, there'll be a 0 here. Okay. Similarly, when I am at, let's say, 2 comma 2 or 2 comma 3, okay, I am here. What choices do I have? Or let me do one thing. Let me write down the code and print it. I think that's much easier to do. So let me just write it down. Okay. So I have strings A, B, X, Y, and I have string A, X, Y, B. So I have string S comma T. I take in C in S, C in T. I have vector of vectors, right? And H dot size, comma vector int T dot size. comma minus 1. Okay. So function int comma int f and int I int j. Okay. So a very simple test case is that both have to be in the realms of the string. So if I is equal to s dot size or j is equal to t dot size, it means that the string is over. So in this case, I will return 0. If dpij, okay, not equal to -1, I will return dpij. Otherwise, I have two cases. Either it is equal or if it is not equal. So if si is equal to tj, return dpij is 1 plus f of I plus 1 comma j plus 1. Otherwise, return dpij is equal to maximum of f of I comma j plus 1 comma f of I plus 1 comma j. Okay. And in the end, we'll just see out f of 0 comma 0. Okay. So it prints 3. Is the code clear, guys? I have integer I have integer j. This was the base case. Like if one of the pointers reaches the end of the string, I'll return 0. If it is not memoized, I'll memoize it. There are two cases: if si is equal to tj, otherwise if it's not. If it is, I will just return 1 plus f of I plus 1 j plus 1. Otherwise, I will return maximum of f of I comma j plus 1 comma I plus 1 comma j. Clear? Ramesh says it is clear. What about others? Put yes in the chat, guys. Let's have an interactive kind of meet. Yes. Yes. 0 comma 0 means first inverse. Okay. Now let me print my particular code, right? So let me just, if I print my DP table, for int I is equal to 0, I less than h dot size I plus plus. For int j is equal to 0, j less than t dot size j plus plus. And let's print out cout dp ij. And let me print out backslash n. Okay, let's do this. Okay. So these are all going to be -1. So just ignore this, right? Okay. So let me just write it down. 3 -1 -1 -1 -1 -1 -1. Just write down 2 1 1 2 -1 1. Okay. Then you just 1 and 1 mazi. So if I start this, okay. So guys, first thing I want you all to know is that we are at, let's say 0 comma 0. We started out here. Okay. What are the two choices we had? First one, while building the DP table, okay, if SI is equal to TJ and SI not equal to TJ. When SI is equal to TJ, do you guys agree we went to I plus 1, J plus 1? Yes or no, guys? You cannot see my screen? Oh, sorry for that. Wow. Yeah. Okay. So guys, thanks for that. Let's say we are starting, this was my DP table. We are starting at 0 comma 0. Okay. Now there were two cases: SI is equal to TJ and SI not equal to TJ. When SI is not SI is equal to TJ, we went to I plus 1 and J plus 1 and we picked that particular string. Yes or no, guys? Tell me. Yes or no? Yes, no. Tell me, guys. Yes. Okay. So when we are at 0 comma 0, my two strings are ABXY and AXYB. So ABXY and AXYB. Do you see that these two characters are equal? SI is equal to TJ. So here I can say that, okay, I'm going to print this out because we are taking it. And then where do I go? I go to I plus 1, J plus 1. Yes or no, guys? Tell me. I go here. Yes? No? Great. Now I am at 1 comma 1. When I am at 1 comma 1, you can see that these two are not equal. When these two are not equal, guys, in our code, it was maximum of f of I plus 1j or f of I plus 1 comma j. F of I comma j plus 1, f of I plus 1j. So do you guys agree that this value right here either came from this value or it came from this value? Yes or no? Put a yes in the chat if you understood that either I will be going down here or down here. And can you guys tell me where I'll be going? Will I be going down or will I be going right? Bottom. Why will I be going here? Because this value 2 either came from down or right. Since 2 is here, I can say that I am going down, which is at 2, comma, whatever, 1. So I'm going to move my I pointer ahead. So I is over here and J is over here. Make sense, guys? Now tell me, what if there was 2 here as well? Then would I have gone to the bottom or would I have gone to the right? Tell me. Now it is 1. I'll change it to 1. But let's say this was also 2. So do we go to the right or do we go towards the bottom? Anyone is fine. Yes, anyone is fine. So someone asked why bottom? Why exactly bottom? Very simply, because dp of I comma j was set up as dp of maximum of dp of I plus 1 comma j and dp of I comma j plus 1. If dp of ij is equal to dp of I plus 1 comma j, it means that my answer comes from moving the I pointer ahead one more. But if it is equal to dp of I comma j plus 1, it means my answer comes from moving the j pointer ahead one more. Since these two are the options and my answer is coming from here, this is dpij, right? It is equal to dpi plus 1j. So that is why I move my I pointer ahead one more. Does it make sense now? For the 200 people watching in the chat, tell me, guys, does it make sense? Okay. So that is why I go down. Now you can see that SI is equal to TJ. So I will print X and then I will move to I plus 1 comma J. Now for I plus 1 comma J, you can see that these two are equal, like this SI is equal to TJ. So in that case, I will print Y and then I will move to I plus 1 J plus 1. Since this is outside the string, I can stop right now. Does it make sense, guys? Like I can implement it for you all as well. But does it make sense? Like we use the DP table. This is my DP table. And I am making sure how to like I'm generating my answer. This make sense? Does not make sense? Tell me frankly. Rami says once more. Okay. So what were my DP transitions? My DP transitions was if SI is equal to SJ, TJ, then I move to I plus 1, comma J plus 1. And I have picked this. But if SI not equal to TJ, I will either go to I plus 1, comma J or I will go to I, comma J plus 1. Now, these two are going to have some values X and Y, right? And we have computed our DP table already. So if my DP of I, comma J is equal to x, it means that the answer came by moving my I pointer ahead one move. And if dp of I comma j is y, it means my answer came by moving the j pointer ahead one move. Okay. So if this is my dp table, what am I going to do? I'm going to start my I at 0. I'm going to start my j at 0. While I smaller than s dot size and j smaller than t dot size. Okay. There are two choices. If si is equal to tj, in that case, I'm going to just print out si. Okay. Let me just print that out. And I'm going to do I plus plus and then I'm going to do j plus plus because I'm moving both the pointers ahead. Otherwise, if I plus 1 smaller than s dot size and si and dp of I plus 1 j is equal to dp of I comma j, then I'm going to do I plus plus, else I'm going to do j plus. Make sense, guys? Tell me. tj instead of tj, yeah, small. Yeah, thank you. If I run this, I hope it runs, and you can see that it prints the xr. Oh, I didn't call this. Yeah. Make sense? Tell me, guys. Why j plus 1 smaller than t dot size? Because I and j are both pointers, so both have to be inside the string, right? It has to point to a character inside the string. If it is pointing somewhere outside the string, you cannot form an LCS after that. Make sense, guys? Does this code make sense? Yes or no? Sir, instead of this, what if we print si in, you can do it in recursive function as well. Like, uh, not here because this is going through all possible combinations. So like, I will show you what happens. Okay. If you, what does f of 0 comma 0 print? F of 0 comma 0 prints the max length or the length of the LCS, which is 3, right? Because AXY is 3. This is your DP table. And then I'm just running a for loop. I've calculated my DP table already, right? I start at 0, comma 0. So if SI is equal to TJ, then I print the character, I move 1 ahead. Otherwise, I have two options. Either it came from down or it came from right. So if it came from down, I go down. Otherwise, I go right. Make sense? Very clean code, very easy to understand. If you have any doubts, please do let me know. Feel free, right? Even though this is a free bootcamp, our aim is to provide quality content. So that is something we don't want to compromise upon. So tell me, guys, is it clear? Clear. Great. So this was the third problem that we were looking at today. The fourth problem, I will, since there are only 10 minutes remaining, I would give it as a kind of homework problem, okay? Because I don't want to rush upon things and I don't want to delay your things. I respect your time. So I'm only going to take up your time till 10 p.m. This problem, it can be taught in the next class as well. There is an upcoming class on Sunday, I believe, where I'll be taking this up. Not a big deal. I'll go through the problem, okay? The problem says we have to find the longest increasing subsequence. What does a longest increasing subsequence mean? That if you choose a subsequence, all numbers before a particular element have to be smaller than a particular element. For example, in the array 10, 9, 2, 5, 3, 7, 1, 0, 1, 18, the longest increasing subsequence is 2, 3, 7, 101. Hence, the length, the largest length of this is 4. So the answer in this case is 4. But we are not going to, our code is not going to print 4. Our target is to print 2, 3, 7, 101. Make sense, guys? Our goal is not to print 2, 3, 7, not to print 4, but our goal is to print 2, 3, 7, 101. So the DP section of this is very interesting. Like we can come up with it. But my question for you all is, will you be able to come up with this by your own? Will you try and get back to me in the next class? I will take it up as a homework problem, and in the next class, I'll be discussing how to implement this so that you guys have something to work upon. Does it work, guys? Tell me. Let me just reload. Yes. Okay. So that was more or less it for today's session then. What we did today was we learned two interesting problems. Then we learned what is answer construction. What is answer construction, guys? When you have the DP table and you want to print the options that you did, it's known as answer construction. So I hope you guys got to learn something today. And I hope I was able to add some value in your lives. We can more or less end the live stream now since I have nothing more or less to share. But if you have any doubts or if you need any tips regarding competitive programming, then feel free to add it down in the chat below. I will take it up since we have 5 more minutes and then we can end. If we look at 2 comma, it could have either come from 3 comma 1. Can we say that if either 3 comma 1 it came from 2 comma 2? Extreme plays, I don't really, I wish I could invite you to the stream. I don't understand what you're trying to say. Nuzat says DP table is not clear. See, we made some choices and we stored our DP table, right? So in the end, if I print my DP table, these are the values of DPI comma J. Now DPI comma J came from some transition. So either it came from I plus 1, J plus 1, or it came from I comma J plus 1 or I plus 1 J. Now, if we look at these conditions, we can more or less backtrack where each value was picked from. Like this 2 was picked from here. And let's say this one, it was picked from here. So in this DP table, start at 0, 0. If both of them are equal, I can say I took this up because this was the condition we wrote. Print it, and then for the other part, we have the other conditions. How to reduce TLE? By analyzing the time complexity. Thanks for that. So what is the time complexity of this? It runs over all pairs I and j, where I is between 0 and n minus 1, j is between 0 and n minus 1. Total time complexity, like the most number of elements here, is n into n, because you iterate through n square pairs. So the time complexity of this is O of n square, because there is no for loop here. It's a O of 1 statement, and then there are n square unique pairs. So the time complexity of this is O of n square, and the space complexity of this, you can see we are only using a DP table, which is n into n. So the space complexity of this also remains big O of n square. Clear? Time complexity and space complexity analysis is very important if you want to reduce TLE. That is one of the tips I'll give you. Apart from that, I think that is more or less it. Thanks a lot for watching. Bye bye. Just stop.